Cool. So I'm starting the recorder right now. And let me see. I don't have my usual clock. Let me get that back onto. Oh, okay. There we go. All right. So here I have a tiny little clock. Stash it here. So this way, if you're watching the recording, it's easier for you to kind of zero into the right moment for the class. So I was just talking a little bit earlier that next Monday is a holiday, so there won't be any class. So next holiday is a holiday, so there's no class on campus whatsoever. Monday, and also this Friday. But we don't meet on Friday, so it's not going to affect us for the most part. So, all right. So let's go back to the material. I just want to remind people again that there is a conditional statement assignment that is due on Wednesday. So please, remember to do that. If you have any questions about the formatting, talk to me. I have office hour right before the class, and I'm usually available after class as well. There are very, very, very few days when I have something scheduled right after this class, but that's very rare. Okay, so typically after class you can talk to me again. Um, all right. Do we have any additional questions before I get started? No questions? All right. Well, I hope that's because you guys have studied and have found that you have understood everything that it has been introduced up to this point, instead of not studying and don't really know what question you need to ask. So that's because that's the other reason why there are no questions. All right, so we're going to get to block statements, or we can go back and revisit, conditions and conditional statements just one last time, just so that you guys can get a sense of, what we have gone through, in terms of the material, and see if you guys have any questions. I think the last topic was um, the else if. Okay, so when we deal with else if, like in this particular example, there are two conditional statements here. The first conditional statement is starting with this if, and it goes all the way through the entire block of code. So that is the outermost conditional statement. It contains everything. The second conditional statement is called nested. It starts on line 4, it ends at line 7. So there are two conditional statements within this particular algorithm. So do we have any questions about the concept of nesting in this case? Okay. And if you want to look at the flowchart, now this is not my problem. Okay, the tool actually had a bug, so this line is supposed to attach all the way up here, but it does not do that. But when you look at this diagram, it shows the yellow block is the nested conditional statement, and then it is nested inside another conditional statement. The shape of a conditional statement is usually it has a start, okay, starting point. It has a decision to make if, and basically it is a question to ask. If the answer to that question is true, then you go to the then block or the then statement. If the condition is false, then you go to the else statement. But either statement will only performs exactly just once, and then they go to a merge point here, and then you exit the conditional statement. So every conditional statement looks like this. Now, whether you have something to do here is, sometimes there's nothing to do if and only if the condition is false, then this particular block can be empty. So that's the only kind of special case where you go like, oh, okay, I have a simplified conditional statement that does not have an else statement in it. And then also there's the syntax description. Are there any questions about the syntax of a conditional statement? So I'm just scrolling all the way back here, and then we look at the syntax of a conditional statement. Do we have any questions about the BNF of a conditional statement? Okay, I don't see any questions. Excellent. So that basically means we are done with conditional statements for now, okay? Because in order to specify complicated algorithms, which is just a fancy word of method of doing something, conditional statements, loops, they're all important. So by the time we have to work on some actual algorithms, we'll come back and use conditional statements. So for the time being, I'm only introducing one kind of control statement at a time. So that's why, I said, okay, we are done with this topic for the time being. Are we good so far? Yes. Yep. Mm-hmm. Mm-hmm. Yep. Mm-hmm. So the BNF describes the syntax, essentially the grammar of how an algorithm is specified in words for us, right? So you can think of this as the grammar. Okay, I'm sure So if you speak multiple languages, you probably notice that different languages have different grammar. Like in Chinese, there are no plurality. Okay, we use the same character whether it's plural or not. So the plurality is actually implied by context. There's also no tense. Okay, yesterday I do, today I do, tomorrow I do. Okay, because it is also implied either by context or we use specific words to establish the timeline. Okay, so in Spanish, there's gender associated with objects. Okay, and in Chinese, there's no such thing. Okay, there's the pronoun for you know gender specific pronoun, and then there's the thing pronoun, just like in English. Okay, so but in different languages, that can also be very different. But that's why we have BNF to specify the syntax or the grammar when you need to use a programming language. And the grammar that we specify in this class is directly reusable in your next class. In Cisp 360, you'll be exactly programming in C++, and the syntax that we describe in this class is C++. So there's no relearning that you need to do when you move on to the next class. Is that okay? Excellent. Yeah, yeah, sure. So the way, so just to reiterate a little bit, so we have a token on the left-hand side of this symbol here. This symbol means it can expand to, and then on the right-hand side of the symbol is how this token can expand to. In this case, everything that is in boldface are called terminals, and those are the things that you have to type as is in your own program. But if you see something that is in italic, it means it is also a token, which basically means it is a placeholder. It is a placeholder which can then be expanded to something else. But there are certain times when I do not expand like certain tokens, like in the case of a condition, I do not specify the BNF for a condition because it is actually very complicated if I were to use the BNF to explain it. So all we want to do is to say the condition evaluates to an answer to a question, sorry, to a question that it can only be answered by either true or false. Okay, and then the then statement, on the other hand, this one here is just a statement. I could have just used statement here instead of then statement, but the thing about using then statement as a token is to emphasize this is what we do if and only if the condition is true. Okay. And then we have an else part instead of an else statement because the else part consists of two components. The else part expands to a word in boldface. So this is once again a terminal. So if you want to specify something to do if and only if the condition is false, you have to use the word else before you specify what statement to execute if and only if the condition is false. So else statement itself expands to just a regular statement, and the most interesting part is statement can also be expanded to a conditional statement. So at this point in time, we already know that statement can expand to an assignment statement. That was in the previous module. So now we have another alternative. A statement can also expand to a conditional statement. So as we introduce more different types of statements, you will see that, oh, statement can also expand to something else. Okay. So is that okay so far? All right. So with that all done, I'm gonna close, some of these tabs here, okay, and we'll get to loops. So this is the topic for today. I'm not sure how far we can get through this, okay. In certain classes, they don't talk about loops until like really like close to half the semester, down the line. I think that is way too long. So we'll go ahead and talk about loops, okay. So the earlier part, the first part of the loop, now I do not expect people to have read this entire module because I just got it released like last night. Okay, so that's my fault, not being able to get this released earlier. But a loop is something that we use to specify repetition. Okay, you have to do something again and again and again. Okay, so can someone give me an example, not related to the movie that we just mentioned, that has repetition in it? Because The Edge of Tomorrow definitely has a loop in it. So we're going to ignore that. Sorry? Could you say that again? Groundhog Day. Okay, so how is the repetition? Okay, well, every day does repeat in a certain sense, so every day has a morning, and then we have an afternoon, we have evening, and then we have nighttime. So there's a certain repetition. What about things that we do? Choosing what to eat. Okay, so can you specify the logic? How do you get out of that repetition? Okay, okay, but that's not core to what is the action that you are doing repetitively, and how do you get out of the repetition? Those are the two key concepts of a loop. Is what are you doing repetitively, and when do you know that you do not need to repeat that anymore? Yes, go ahead. Hmm? Reincarnation. Okay. Yeah, that's an infinite loop, right? And that also depends on the religion. Okay, some religions do not have the loop concept. It's a one-shot deal. So we're not going to get into that. Yes. Um, okay, let's try something easier. Okay, so let's just say that it is time for you to enroll in classes in fall 2025. It is a loop because every time you go through that process, you can only enroll in one class. Okay, and it is a complicated process to even to get to that one class, right? So because you have to look at the schedule, find out what classes you can take, what time slot you can use, and so on and so forth. But eventually you will find one class and go like, okay, I can enroll in this class, done. Okay, that will give you like 3 or 4 units. Okay, most of you probably want to have at least 12 units. So now you have to go like, I have not met the minimum requirement of 12 units yet. So I need to go find me another class. So there is that repetitive action. Okay, it's something that you have to do multiple times. How do we get out of that loop? Well, the moment you enroll in enough classes to give you enough units, and you think that that's the maximum of units that you can handle, then you're done. So you have a condition to get out of the loop, to conclude the action, to conclude the whole process, and you go like, I don't have to do this anymore because the condition has been met. Is that okay? All right. So in programming, the concept of a loop is just as important. So we have a really kind of stupid example here to specify how we eat. Okay, because let's just say that you have a prepared meal. Okay, you know that it gives you, all the nutrients that you need. Okay, it has all the calorie that you need. It has protein. It has all the vitamins, minerals, and whatnot. Okay, what are the chances that you can take it all in one shot? Mm, that's not going to happen, right? So that means that you're going to have to take one bite after another bite and so on. Okay, so that's also repetitive. Okay, because the whole process of taking a bite is something that you have to repeat multiple times, okay? But the number of times that you have to repeat that particular action depends on a lot of factors, okay? It depends on the food that you're eating, okay? Certain food you just cannot take a huge big bite, okay? Otherwise you're gonna choke. And other types of food, maybe you can take more, okay, per bite. And it also depends on how hungry you are at the time, okay? So if you're super hungry, it will take you more bites, okay, to feel full and sated. But if you're already kind of halfway there already, you just need a little snack, maybe a few bites is more than enough. So that's kind of the example or the backdrop of this example. So we can say, okay, this is actual C syntax. So we are using C syntax here. So we start with the word do, okay? So the word do here does not actually do anything, no pun intended, okay? So the whole thing, the whole point about do is to tell the compiler what follows is going to be a loop. That is the purpose of the word do. It is just a marker so that the compiler can say, oh, I know what I can expect after that word do. Okay, so the word do itself doesn't really do anything when we are executing the code. And then you specify the statement of what you want to do repetitively. So in this case, taking a bite is the action that I might need to do repetitively. And then after that is the word while. And the word while in this case is also kind of a marker. It serves multiple purposes. It marks the end of the action that you want to do repetitively, but it also says, oh, whatever follows, okay, whatever is following the while is going to be in parentheses. And inside the parentheses would be a condition that you need to evaluate. In other words, it is a question that you need to answer. The answer to that question has to be either true or false. Now, I didn't quite pose it as a question because the question, if I want to use the long form of the question, it would have been, is it true or false that one is still hungry? Okay, but I just kind of simplified to one is hungry. Is that okay so far? Okay, so that is basically what these words are explaining. I'm just describing everything just kind of verbally. So when we trace this code, and let's just say that someone is not particularly hungry, and it only took 3 bites to be full. So that the loop here is going like this. It's probably better off if I can show both the code and the trace at the same time. So let me see how I can do that. So I can use one half of the screen for this, and then get myself another tab, and then move this tab to its own window, put that tab side by side without triggering the maximizing, and then just copy and paste the URL, and then move to the algorithm part. Okay, so now we can both see the algorithm, which is here, and it has line numbers, and also the trace corresponding to that code. So line one, interestingly, is something that we normally do not trace, okay, because it really doesn't do a single thing. It's just a word that starts, the description of the action. But in this case, I'm going to trace it anyway. And then line two is going to take a bite. In other words, the first time you take a bite is mandatory, okay? According to this code, you do not have an option of, I'm already full, I don't need to take a bite because you asked the question after the action is performed. And then on line three, finally, we ask the question, the condition is evaluated, and I mentioned in this case that person needed 3 bites in order to be full. So after 1 bite, that person is still hungry. And then what we do is, so once line three is done and the condition is true, then we go back to line one again. Okay, in other words, we repeat the whole thing. So we go back to line one. This part is kind of important because we get back to this point. That's the whole concept of a loop is it goes back to an earlier point of the algorithm. So we take a second bite on line two, And then on line three, we evaluate the condition again. Remember this time I said that person needed 3 bites. So after 2 bites, that person is still hungry, which means the condition remains to be true. So we go back to line one again. We go to line two. This is our third bite. And then at this time, that person is not hungry anymore, which means one is hungry is going to be false. And when that is false, we don't have to take yet another bite, and then the algorithm exits. And so we use a post here to indicate, okay, we're all done here. Are we good so far? Now, I should have used a pre a little bit earlier to kind of state that that person needed 3 bites, okay, in order not to be hungry anymore. But I didn't do that. I forgot. But are we okay with the concept? Okay, can we correlate the description in the algorithm with the trace to get a general idea of how this works? Okay, I see a few nods. Okay, do we have any questions about this? Okay, so I'm going to introduce the flowchart corresponding to this particular loop or do loop. So it looks like this for this specific algorithm. It has a starting point. Okay, it's always good to identify a starting point for any algorithm. So in this case, we have a starting point, and then we have a diamond here. The only purpose of this diamond is to merge the two incoming paths. One incoming path is coming from the start terminal, you know, circle, ellipse kind of thing. They call it the stadium. And then the other incoming path to this diamond is after the action is performed. So that means you start at the beginning, you come here, and then it only has one exit point. Okay, this diamond only has one exiting arrow. So you go straight to take a bite. After you take a bite, you go to this decision making process, the diamond. The diamond is asking the question, is one still hungry? So at this time I did put a question mark here to emphasize it is a question. Yes. You mean this diamond? The diamond serves the only purpose the diamond is serving in this case, because you cannot have two arrow going into a block like this in a flowchart. So to be I mean strictly speaking, in a flowchart, you can only use diamonds to merge two incoming paths to one outgoing, or to split one incoming path into two outgoing paths. Yeah, yeah. So it's more or less just an organizing kind of construct. Yep. That's a good question. So when we ask this question, is one still hungry or not? Okay, the answer is either true or false. If the answer to that question is false, which means that person is no longer hungry, then we go to the end, the other terminal. If one is still hungry, which means the answer is true, then we go back, okay? And that is why it is a loop, because it goes back to an earlier point so that you can perform the action again, whatever that action turns out to be. Yes. To exit the loop, well, the only way to exit the loop is to answer false to this question. So in this particular example, the moment that this person says, I'm not hungry anymore, that is when you exit the loop. But you can only ask that question after taking a bite. So that brings us to a problem with this logic. What if that person was not hungry to begin with and get to the starting point of this particular flowchart? Is there a way in this diagram to skip even taking a single bite? Nope. There's no option to skip the first bite, okay? So that's the problem with a do while loop, because we ask the question. The only way to get out of a loop is after you perform at least one iteration of the action. Is that okay? All right. So are we doing okay so far, correlating a few things? This is what the pseudocode would look like. Obviously, there's no C code of taking a bite or to evaluate whether one is hungry or not. So this is actually just a kind of pseudocode, but I am still using C syntax in this case. So are there any questions correlating the pseudocode with the trace which is basically, kind of like a movie that you make when you execute the algorithm. So each row of this table is basically a frame in a movie, or any questions correlating the pseudocode with the very clumsy and much bigger representation as a flowchart. Do we have any questions correlating all of those items? You good? Hmm? Mm, I would not call it. It's more like just syntactically we need a marker to so that the compiler knows. Oh, okay, you are starting a loop of this kind. It has the same purpose, syntactically speaking, from the perspective of the compiler. So the compiler is essentially a translator, okay? The, because the processor inside the computer, they execute what we call machine code. Okay, they're all in zeros and ones, and no one, okay, no human can actually program a computer using just the opcode, not feasibly, okay? Can I do it? Yes. Do I want to do it? No. Okay, so the code or the representation of instructions inside the computer is not friendly at all to a human. Okay, this code here, okay, what we see, in the conditional statement, assignment statement, and stuff like that, it is actually considerably easier for humans to understand. Okay, so I understand that in this class, some people may still find that the syntax of C++ is a little bit difficult to learn, but by comparison, it's actually much better. So now you have something that we can understand fairly easily with some training, we can do it. And then on the other hand, we have some binary instructions that we absolutely really cannot do it, unless it's just a few instructions. Okay. So the compiler is the translator. Okay. It takes the description of C++, okay, which we have been talking about in BNF. So the compiler takes that description and turn it into machine code. It converts what we can easily understand into machine code, which is what the processor understands. That's the compiler. Okay. So in your next class in CISP 360, you'll be using the compiler a lot, okay? Because you'll actually be writing code and you'll be running the compiled code on the native processor. So things will happen a lot faster because in this class, I am only going to trace the code using a table by hand. Okay, is that okay? All right. Do is a marker. Yep. The actual action is to take a bite, and then the question to ask so that you can determine whether it's time to exit the loop is whether one is still hungry or not. Yep. hmm So I think it is kind of because the complexity of this class is we're introducing the C syntax in BNF, we're introducing the logic as specified here as a flowchart, and we're also using a trace to illustrate what happens when the code executes. So there are three different aspects, at least at the beginning of this class. Eventually, I won't use flowcharts anymore. Okay, so the flowchart is only here to help you understand what is the syntax specifying. So we only use the flowchart at this point of time. But later on, I'm not going to use flowcharts anymore. Is that okay? Are there any questions regarding what I just talked about, the three aspects of an algorithm? The BNF description, the syntax, how do we use words to describe what we want the computer to do? So that's BNF. The flowchart, which is a pictorial way and more intuitive way so that people can just follow the arrows and go like, oh, okay, I understand the logic here. And then the third one is the trace, which is, as we execute the algorithm, what is happening to the variables? So those are the three different things that I try to introduce at the same time because they help reinforce each other. Are we good so far? All right. And somebody may notice that I have not introduced the BNF of the do loop. So we're going to do that right now. So we just have to go past the flowchart, and now we get to the syntax of a do loop. So the do loop is also known as a post checking loop. So, okay, can everybody understand why it is called a post checking loop? Post means what? After, exactly. So it is after the action that we perform the checking of the condition. So I call it a post checking loop because those words describe exactly the nature of the logic. You check only after you perform the action. All right, so I'm going to pause a little bit here from the main content. If I call this kind of loop a post checking loop, are you anticipating something else? A pre-checking loop. Okay, I like that. Okay, so that means you are paying attention, you're contrasting and go like, if this is the only kind of loop that we have, I have no need to call it a post-checking loop. So the whole concept of calling this a post-checking loop means there's another kind of loop where the checking is at a different time. Okay, and to con can may I finish my sentence? So the contrast of post is pre. Okay, so those are the kind of thing. That's the kind of thinking that I want to encourage the whole class to use, is to kind of anticipate a little bit. Okay, based on what we are talking right now, anticipate a little bit based on the clues and go like, okay, if there's a post checking loop, there's probably a pre checking loop. Okay, contrasting the post. Yes, go ahead. Yes, you may. You don't have to ask me. Yep. Okay. Um, all right, so getting back to the BNF or the syntax. So the syntax of a do loop is actually pretty easy. First of all, a statement can expand to a do statement. So now we have three different alternatives to expand a statement. We have the assignment statement, we have the conditional statement, and now we have the do statement, which is a post-checking loop. Okay, so we are going to add one more, and then we are done with the control structures. So we are only going to talk about do and while loops and also conditional statements in this class. The actual C++ programming language also has switch and for loops, but they are not super essential. They can be emulated by what we talk about in this class. So I'm only going to cover the fundamentals of programming and not to cover things that are like, oh, okay, this looks nicer, okay, but essentially it boils down to something that we already know how to do. All right. So a do statement expands to, okay, we already know this. Okay, I gave you some examples. So expands to the terminal do, followed by a single statement, followed by a while word, okay, which is also a terminal, followed by open and close parentheses, but inside you have to specify the condition, which is basically a question that has an answer of either true or false, so that you can determine, okay, are we supposed to exit the loop now or not? Is that okay? So that's the syntax of a while loop. I believe I skipped one module up to this point, because every time when we specify a conditional statement, the then statement and then the else statement can only be a single statement. When we have a do while loop, it is also a single statement, which means what if we have a bunch of stuff that we want to do? Did I talk about the block statement? I think I mentioned the block statement, but I did not go to the module. So let me kind of go back to that module. So we'll leave this one hanging at this point, but I'll go back to the block statement. So the concept of a block statement is actually before the loop concept. So we'll go here and open it in a new tab. There we go. All right. So all of these modules, I try my best to give you a prerequisite link. So this way, if you would know what you need to know first or what is the context of this particular one. This is a really short module, okay? Because all it wants to do is to say, what if there are multiple things that we need to do? I believe the example that I used or the analogy that I used to explain this concept was, what if in Canvas, okay, one of the professors, one of your classes, you need to turn in something, as a file upload, okay? But the professor forgot to allow multiple file upload. but you actually have to turn in multiple files. So what do? Zip. Okay, you just multi-select those files in your file manager, right click and say add to zip to create a single zip file. You upload that one single zip file, and that's basically, it can be seen as one file when you're uploading to Canvas. Then your professor, when he or she is grading it, then your professor can expand it again into the multiple files that are inside the same zip file. So I was using that as an analogy. So a block statement does exactly that. Okay, you have multiple things that you want a particular branch of a conditional statement to perform. Then what you do is you use a block statement. So the block statement in terms of BNF, a statement can also expand to a block statement, and a block statement expands to the following. And this part here is my fault because the vertical bar is not interpreted correctly. I'll fix that later. So the open brace is a token. The closed brace is also a terminal. So that means the way you specify a block statement is to use the braces. Most people call these curly braces, but you don't actually need to specify the term curly, because braces always refer to these two particular symbols. Brackets are the ones that are square. Parentheses are the ones that are round. Okay. All right. So let me go ahead and fix this first because I need to finish up the introduction of the BNF. So I'm gonna go ahead and fix it. And this is basically how everything is typed. When I type the notes here, this is how it looks like. The problem has to do with this vertical bar. The interpretation of the vertical bar is, oh, let's turn it into a table, but that's not the intention. So that's why I have to fix that one. And then we go back and we commit changes. And then we have to let it bake for about a minute or so, which is not terrible. And I'll just kind of park here for the time being and let it bake for about a minute or so. So talking about baking, have you guys played with 3D printers and do some 3D modeling and 3D printing? Not yet. Okay. Mm-hmm. So with 3D printing, the first thing is you have to get the model. Okay, you can download a bazillion models now. I mean, there are some really cool stuff on online on the internet. I found one that is a cat food dispenser. So the way it looks like is it looks like a tumbler, and then below the tumbler is a surface that has a lot of ridges and whatnot. So the idea is you fill it up with cat food, and then the cat has to turn the tumbler in order for the cat food to be dropped like one by one. Okay. But once it drops into not a flat surface, but a surface where there are a lot of ridges and whatnot. So the cat actually has to exert some time do some time to actually get the cat kibble out. And I can understand the necessity of that kind of thing because my cat inhales cat food. There's no chewing sound, there's no crunching sound with dry food. you know he just swallows everything whole. And then in about a minute or so, what's going to happen? Throw up. And guess who's going to have to clean it up? Right? So, you know, that kind of a device is good, because it gives the cat a little bit of delay. It's like, okay, you cannot just inhale like a whole bunch of your cat food. You can inhale the cat food one by one, one piece at a time, but you cannot inhale like your several pieces all at the same time and then choke. So anyway, because when I mentioned the word baking, it reminded me of your 3D printing. Yes. So unfortunately, you have a professor who has ADHD. So that's this sort of thing happens. Okay, something would just remind me of something else and go like, oh, okay. And if it is relevant, I will still kind of mention it in the class. Okay. So now we get back to to the PNF. So statements, which is optional inside the braces in the block statement. So first of all, This is optional, OPT. What does that mean? It means it's optional, but can somebody tell me using another way to describe what does optional mean? Hmm. But it doesn't need to be there, right? So that means you can make a blank block statement. Okay, and blank also has BLK in it, but that's not BLK means. This BLK means your block. But a block statement can have nothing between the braces. It is still considered a block statement. So that means it is also useful as a placeholder sometimes. In other words, you haven't really quite figured out what to do in a conditional statement for the else portion. You know that there is something you need to do, you just have not figured out what to do. You can always use a block statement with only the open and the close braces to mark the place. It's like once I figure out what I need to do, it goes here. Okay, it's kind of like a reminder. It's kind of like a placeholder, a reminder that okay, if once I figure out what to do, it goes here. Anyway, so a statement can expand to, okay, we have seen this kind of thing before. It can expand to a single statement, or it can also expand to statements again and then followed by a single statement. This is just a fancy way to say that statements expand to one or more statements. Okay, let me rephrase that because that sounds really confusing. It means the token statements expands to at least one statement, but it can also expand to multiple statements, as in statement plural. Is that okay? All right. And that's it. Okay, so I have one example here. Okay, so in this first example, a beginner, especially one who has learned Python first, which is all your. Once you get to CISP 360, you will find that everybody else learned Python in CISP 300. So when they look at this code, they would think that line 2 and line 3 are both what you need to do if and only if x is not y. Okay? But in this class, we know better. Okay? What do we know about conditional statements? You only have one statement associated with the then portion. So that means line 3 is not a part of the conditional statement at all. The condition, which is x does not equal to y, will determine whether line 2 executes or not. Line 3 always executes because line 3 is not a part of the conditional statement. Is that okay? Okay, so the way we look at this, okay, I know you guys are nodding, but I'm not really sure whether you're actually fully understanding this or not. So let me hmm, let me use the tablet, okay, because I think a tablet can help explain this. Because this can only be explained when you understand what the compiler does. Now, understanding what a compiler does sounds like something that is way out of the scope of this class, but I think it is actually very important when you want to pursue computer science as a career is to understand how the machine does it. All right, so I'm going to use a tablet here, and let me. Oh, okay, it needs to be. Need to wake it up, and then we go to Notepad and get a new page. There we go. All right. So what I'm going to do is I will replicate the syntax or the actual statement until. Okay, let me give myself some time here. I'm just writing everything down right now. If x does not equal to y, how many people remember the exclamation point equal to means does not equal to? You don't actually have to answer my question, but I think it is important that you study the material of this class enough that at least know where to find it. Okay. Yeah. So when we talked about conditions, when we talk about conditional statements and conditions, we talked about comparison, the six comparison operators being less than or equal to, greater than or equal to, and not equal to. That's when we introduce this particular symbol. Now, do you really have to memorize everything to the point that I can point it in the class and then you have to be able to regurgitate that? The answer is no. Okay, at least know where to find it. Okay, because the exams for all of my classes, not just this class, they're always open book and open notes. But they have to be on paper. Okay, so no tablet, no laptop computer, no cell phone. Okay, but they're always open book and open notes because it is not a good use of our neurons to memorize things. Okay, we are better off, solving problems and trying to figure out things instead of memorizing things. Now, certain things you use it enough times that you end up memorizing because you have used it so many times. It's okay. That's not a problem. You just have your brain develops shortcuts to improve the efficiency. That's okay. But for something like this, I don't want you guys to waste your brain power to memorize something, but you need a way so that you know where to find the definition of that symbol. So what do you think you need to do, to prepare for the exam and go like, okay, I can bring any number of pieces of paper or books or whatever, okay, to the exam. There's no limitation. But even so, how are you going to prepare for the exam? You can practice, okay? That's at least to the point you know where to find it, right? Some people think, okay, if I just print everything that TAC has given us in this class, that should be sufficient. It should contain everything that you need to know. The answer to that question is yes, okay? I would know exactly where to find something because I wrote that. Did you write it? No. So what is the likelihood in the pressure of an exam that you know exactly where to find the definition of a particular thing? So basically, you're creating your own index, to the different material. You can also do what I would propose, okay, which is to work on your study guide, okay. Now, don't ask me for any study guide for any of the exams because I cannot give you a study guide. A study guide is something that you have to create and maintain with every class. Okay, which means when we introduce a concept, you write down some notes, on paper or on a tablet, and then after class, you clean that up, okay, and you create a condensed version, a digest of all of that stuff. And what I would typically do, when I'm learning a new programming language, is I would put all the definitions, all the symbols, and all the syntax, into a particular sheet of paper, so it's easy for me to look up things. So that is exactly, because I wrote that piece of paper, it is easier for me to recall, oh yeah, I think it's on the second page of the study guide. So the study guide is not something that I will provide. It is not something that you can create just a week before the exam. It is something that you continually create, maintain, edit, revise, condense, and so on. Okay? The only thing you have to keep in mind is you have to be able to print it out. Okay? Because some of you may use a tablet to try to jot down everything. So you just have to find a good way to print everything out on pieces of paper. Is that okay? All right. So um, I know there are people in this class who might have taken Java in high school and might even taken the AP exam, in high school. So none of this is truly new to those people. That's fine. Okay, so those people don't need to take notes because they are already familiar with these things. But for people who are new to programming, taking notes and being able to maintain that note is really, really important. Okay, since you're in CISP 300, some of you are relatively new to college level classes, so that's why I really like to teach the introductory classes as well as the capstone classes, because this is when I can introduce these study skills and you know tips, so that people who may not have exposure to how to take classes at the college level would now know what you need to do. All right. So for anyone who wants to know even more, like, how can I improve, my study skills and whatnot, well, just come to my office either before or after this class, and I'll be more than happy to talk about those things. Anyway, I am done with this. Okay. So I'm switching to the tablet right now. Okay. I put everything on the same line, okay, where you saw on the screen. Because in C, C++, Java, and most programming languages other than Python, it doesn't matter whether you put a space between something, you put a line feed, which means you break it up into two lines, or whatever, okay? It still means the same thing to the compiler. So now what do? We pretend that we are the compiler. So the compiler first, sees the word if, and it would immediately understand, oh, we're dealing with a conditional statement here. Okay, so that's the purpose of the word if and do, okay, up to this point, as well as open brace, okay, because it tells the compiler what can I expect. So at this point, the compiler goes like, okay, I am creating a template here, okay. Once I see the word if, I'm also expecting open paren, some kind of a condition, a close paren, and a then statement. Okay, now whether there's an else statement, that's optional. Okay, so that means, I'm going to use dotted line here, okay, to say that, okay, maybe I will see an else followed by an else statement. In other words, all of this stuff here, the compiler does, it will have these expectations as soon as it sees the word if. Is that okay? Okay, so I'm describing a little bit of the mechanism of a compiler, but understanding that mechanism is actually very important, because it really helps to look at the other side of BNF, which is, not just the notation of BNF, but also how it is applied in the context of an actual programming language. So now what does the compiler do? Well, the compiler says, okay, I'm expecting an open parenthesis. So it will scan the actual input and go like, cool, I'm seeing that, okay? And then it will see the expression here. And I'm not going to talk about the actual analysis of the entire expression, because once again, that is really, really complicated. But it will understand that, oh, that's a condition, okay? Cool. I feel this, I feel the condition um, token or placeholder, because I see, x does not equal to y. And what do I expect after that? Oh, right. I expect to see a close parenthesis here. And the input also actually has the close parenthesis. It's all good, right? No syntax error whatsoever. It's all good. So now the compiler moves on and see the word or the character x. So now the compiler says, okay, is this one of the known beginning words of statements for me? Let me check. I can see a if for a conditional statement. That's not it. And then at this point, we have already introduced the do loop, right? So is that do? Nope, it's x. Okay, so it's not a do loop. So at this point, and can it be? Is it an open brace? No, it is not an open brace. So now the compiler says the only thing I can possibly expect is an assignment statement. Is that okay? So now the compiler says, okay, I'm expecting an assignment statement. So now the compiler says, okay, what is an assignment statement? An assignment statement has a left-hand side, a single equal, a right-hand side, and then a semicolon. That's the expectation of the compiler. So now the compiler, knowing that this has to be an assignment statement, goes like, okay, x goes to the left-hand side, then I expect a single equal symbol. Yep, I'm seeing that. And then I expect an expression, which is the right-hand side. I'm seeing that too, followed by a single semicolon at the end. Woohoo! Everything matches. Okay, so everything here then becomes a single statement, and that single statement fills the role or fills the placeholder of then statement. Then at this point, what is the compiler expecting? The compiler says, well, maybe I will see the word else, which then will specify the else statement. But at this time, the compiler sees the word or the character y. Okay, so the compiler goes through the whole process again. What can this be? Okay, it is not do, it is not if, it's not an open brace, so it has to be its own assignment statement. But most importantly, it is not the word else, which means the else statement part here, the optional part, the compiler at this point knows there's no else statement. So without the else statement, the compiler says, oh, that means the conditional statement is all done. This is the entirety of the conditional statement that we're dealing with. In other words, y gets y minus 1 is not a part of the conditional statement. It is a statement, but it's a statement that is entirely after the conditional statement. Are we understanding the concept? You might need to watch, and listen to the lecture again if you're not quite getting it the first time. But the important part here is, oh, okay, so even though the syntax or the way I use spacing seems to suggest that line 2 and line 3 belong to the else, excuse me, to the then statement of the conditional statement, that is not true. Okay, so that means, right now, okay, so how do we specify both line 2 and line 3 to be part of what we need to do? So the answer is to use a, a block statement, which begins with an open brace, ends with a close brace, because now line, I call it 1.5 because it's between line 1 and line 2, and also line 3.5 because it's right after line 3. So now everything from, okay, the most important part is line 2, line 3 now become a single block statement. And that one single block statement becomes the then statement of the conditional statement. Is that okay? It's similar to the analogy that the conditional statement says, I'm only expecting one file to update, to be uploaded. Okay? And you go like, but I got a bunch of files that I need to upload. What am I going to do? There's a restriction of you can only accept one file. Open brace, close brace makes a block statement. That is your quote unquote zip utility. It combines everything between the open and the close brace and say, let's just treat this entire thing as one single statement, as quote unquote one file. So now, any place you expect one single file, this entire block can go there. Is that okay? So that's kind of the discussion of a block statement. And typically, when people write a block statement, instead of using the open brace on one line by itself, they typically put it on the same line as whatever control structure that is needing the block statement. But that's just eye candy. Okay, so it's just a style of how you want to put where you want to put your open brace. So best practice over here, is to use a block statement whenever there may be a need to specify multiple statements. So you don't wait until that, oh, wait, I got two things to specify. Even if you only have one thing to specify, use a block statement anyway, because that allows you the freedom to add additional statements later on without getting into the problem that we were describing earlier. All right, so we're going to take roll now. Okay, so please log into Canvas and go all the way to the bottom of this Canvas module. And I'm making the activity visible to you. And I will show you the actual access code, which is highlighted on the projector right now. While, WHILE. All right. So I noticed in the previous few classes that some people I know they are physically here in the class, but they did not take roll. Um, I think I dropped at least one of those people, and then later on that person says, "But I was in class." Well, if you're in class, please use the Canvas tool to tell me that you are actually in class. So have you taken roll? Okay, good, excellent. Does anyone need more time for the roll taking activity? No. Yes. Can you? Well, that's why I asked you. Have you taken the roll already? So you guys need to. Okay, not you guys, but paying attention is important. Okay, just okay. Hmm. Oh, you took it already? Okay. No, the access code is on the whiteboard, highlighted. Yep, that's what I said. Okay. So try your best not to get distracted in a in-person class. The whole idea of an in-person class is it's not as easy to get distracted. Okay. WHILE, all lowercase. Yep, submit. This is like the fifth time we do it. So, all right. So, is everybody else okay? Done with this? Okay, very good. So, we can just go back here, and it's getting refreshed. Okay, it's all good. All right. So we are now getting back to loops. Okay, we are done with the block statement because I just noticed that I missed that. All right. So this is the while loop. Okay. So now the next type of loop is called a while loop because the problem with the first kind of loop is, oh, we're always going to take a bite. Okay, according to the flow chart, we take a bite first and then we assess, are we still hungry? Well, if you go to a buffet place and you just walked out and you're filled to the brim already, and then somebody asks, hey, you want to go get some ice cream? That means you're going to have to take a bite of the ice cream, even though you're filled to the brim and you're almost ready to throw up, like my cat, right? You still have to take that one bite. You still have to take one bite of the ice cream, which is not good, okay? So we now have a different kind of loop. It starts with the word while instead of the word do. So once again, the purpose of the word while is a marker, okay? It tells the compiler what to expect after the word while, okay? And it is very similar to a do while loop in the sense that you have open parentheses and then you have a condition specified between the parentheses and then you have an action to perform after the while and then the parenthesized condition. So the syntax is awfully similar, but the logic is different. So in this case, if somebody is already full, okay, so in this case, I'm specifying the example or the flow chart, not the flow chart, but the trace is for someone who is already not hungry. Okay, that person just came out of a buffet place. It's like, oh, I'm filled to the brim. Okay, so what logic or what is the trace of the logic for that particular person? So this is the trace. It is really simple because we just go to line 1 of this code. We ask the question, is 1 hungry? Is it true or is it false? If the answer is false, then we exit the loop. Well, but when we exit the loop, there's nothing here in this pseudocode to specify anything else. So we go straight to the post condition to conclude the execution of the while loop. So in this case, we have to ask the question, but we are asking the question first, which can then determine, oh, you don't need to take a bite. Okay, we just go like, okay, we're done, we're good. As opposed to the do while loop where you always take a bite first and then you ask the question, are we still hungry? So this one is a little bit different, and that's why it is also called a pre-checking loop because you check the condition before you perform the action. So the flow chart is a pre-checking loop because you check, then you perform the action when you need to. So the flow chart of this looks, the tool that I used for formatting the flowchart does not really do the best job, placing the components. But since we only need to follow the arrows, it's not a big deal. So you start, you go into the question first. You always ask the question first. Is one still hungry? Okay, typo here, G, okay, instead of T. So is one still hungry? If the answer is true, then you follow this branch here, and then you go take a bite. But what do you do after you take that one bite? You go back and ask the question again. Okay? So you keep doing this, okay, until what time? Until the answer to the question is false. Then you follow the false branch and then you terminate the loop in this case. Yes, go ahead. Yes. Yep. Yep. hmm So which loop do you think is more popular or more frequently used? The while loop. That is correct. Okay, checking the condition first is typically more common. The only time you use a do loop is when the action is influencing the condition. So I can give you one example. Okay, so let's say you're writing a program where you have to ask an end user for a zip code. Okay, so in that case, and you're validating the zip code, you're making sure that the zip code is valid. So in that case, a do while loop makes more sense because you basically say do and then prompt the user for the zip code, and then you say while the zip code is invalid. Because as long as the zip code is invalid, you want to ask again and again and again. Okay, so that's one of the very few occasions where a do while loop makes more sense, but most programming um, situations require a while loop instead of a do while loop. Okay, so in other words, if you think about, okay, I'm creating an algorithm, I need to repeat something, more likely than not, okay, you want to use a while loop and not a do while loop. So now we kind of move ahead and talk about the flow chart. Okay, this is done already. And now we go to the syntax part. Okay, so if I go to the syntax part, I want to go back to the actual code here. So a statement can also expand to a while statement. A while statement expands to the terminal of while followed by parenthesized condition and then followed by a single statement. And that's it. I have introduced all the control structures that I want to talk about in this class. Can someone kind of guess what I mean when I said the phrase control structure? Yep, yep. The control part controls the flow. Yep. And now we have introduced every control structure that I want to go over in this class. The actual programming language has a few more, but they can be emulated by the ones that we have already talked about. So that's it. Okay, so now we have all the control structures. And in this one, I think that I made oh, maybe I forgot to check it in. I thought I made an example, but it's not showing up. Oh, it is showing up. Okay, I was using O tab before I refreshed. Okay, so here is an example, okay, because I think this is a real example, by the way. Okay, this code actually will compile once you put it inside the function and all that stuff, but it is actual C syntax. So we have lines 1, 2, 3, and 4, and now we want to say, okay, what happens when we trace this code? So this time I'm going to reverse the row of the left and the right panes. So in this case, I would use this side to illustrate what happens when we trace the code. when we trace this code, now this one is a full trace. Okay, so when we eventually have a homework assignment on loops, this is the format that I want to use. Okay, so that means that you have to have the same elements in your trace in order to get full credit for your homework assignment. Well, for tracing in general, okay, so I'll describe in general what I expect in a trace. So in this case, it starts with a pre. Okay, we always want to start with a pre in a formal trace. In other words, for any homework assignment or in the exam. Okay, you always start with a pre. For every variable you need to say either I wasn't told what it is supposed to start with, or you specify the starting value of the variable. If I told you, assume variable blah has a value of blah blah blah. Okay, is that okay? Does everybody understand the role or the purpose of the pre line? Okay, good. So now we start with line one. And what does line one do? What is line one? What kind of a statement is it? Okay, we have we have mm, mm, we have five different types of statements. Okay, let's name the five different kind of statements. Assignment statement that was first introduced. Then we have the conditional statement that starts with if. Then we have a block statement, which starts with an open brace. Then we have the do while loop, which starts with the word do. And then we have the while loop, which starts with the word while. Okay, so only just from the syntactic perspective, what is line one? Yes. Mhm. To X. That is correct. So from the perspective of looking at the entire thing, we see that it is an assignment statement because it involves the use of a single equal symbol. From the compiler perspective, we know it is an assignment statement because it is not starting with if, it's not starting with do, it's not starting with while, and it's not starting with an open brace. So the only option left is an assignment statement. Okay? So yes, so x equals to 0 is an assignment statement, which means it is going to have an effect on the left-hand side or whatever is specified on the left-hand side, which is x, and that's why x is updated to a 0 at this point. Line 2 needs to be traced. When we trace a line that has a condition on it, the comments of your trace need to specify what happens to the condition. Does the condition evaluate to true or does it evaluate to false? Okay. Now, does it have to be this long? No, it does not have to be this long. Okay, this is me explaining what line 2 is doing. So line 2 is evaluating the condition of x is less than 3. It's basically asking the question, is it true or is it false that x is less than 3? Well, x has a value of 0. So what do you think? It is true, okay? 0 is less than 3 is true. So that is the reason, okay, in the case of a while loop, that is the reason why we move on to line 3, because line 3 is inside a block statement, which is the body or the action to be repeated in the while loop. So we perform whatever is on line 3. Once again, line 3 is also an assignment statement because it doesn't start with if, doesn't start with do, doesn't start with while, doesn't start with an open brace. So we perform that action. X gets x plus 1. It's an assignment statement, which means we evaluate the right-hand side. X currently has a value of 0. 0 plus 1 is 1. We use the value of the right-hand side to specify whatever we specify on the left-hand side, which is also just variable x. And as a result, variable x is updated to a value of 1. Now, in a homework assignment, you don't have to write any comments for assignment statements, okay? You only want to use the comments your column when you have a condition to evaluate. Then you have to tell me what is the result of that evaluation. Now, I put a lot of comments here because this is my way of explaining to you, what's going on when the code executes. So after line 3, yes, go ahead. No, you can always put more stuff down, as long as you meet the minimum requirement. Yep, definitely. You can put more things down just to help explain to yourself. So then we go, so from line 3, we go back to line 2. So this is a signature that we are dealing with a loop because only in a loop that we go back to an earlier line. Conditional statements do not do that. Only loops do that. Okay. So in this case, we go back to line 2 because after we perform the action inside a while loop, we have to go back to the while part, okay, which is line 2 in this case, and re-evaluate the condition. X has a value of 1 right now. 1 is less than 3 is also true. So we go back to line 3, X gets incremented again, but this time to 2. Then we go back to line 2 and then reevaluate the condition. 2 is less than 3 is still true. Then we go back to line 3. And then finally, this time we increment the value of X to 3. We still have to go back to line 2. In other words, most people look at this code after a while to get used to this kind of code and go like, oh, okay, we are done. Well, no, we are not done until we go back to reevaluate the condition and document that the condition 3 is less than 3 is now false. Then we are done. Sorry? Hmm. What do you mean by both? There's only one condition here. Well, true and false are the possible answers to the question. But every time you ask the question, you only get one or the other. So we have been getting the answer of true before this, but this is the first time because now x has a value of 3. So when we ask the question, is it true or false that x is less than 3? Then the answer is false because x has a value of 3. 3 is less than 3 is false. And only at that time we go straight to post because this is the entire algorithm. There's nothing else I need to do. Yep. So do we have any questions about the trace? Not this one? Okay, very good. Yep, go ahead. It is it's the structure of a while loop. So the structure of a while loop is the while is just a word that tells the compiler what else to expect, which is the condition, and some kind of action that you want to do potentially repetitively. But after you perform the action, you always go back to reevaluate the condition to see whether you need another iteration. It is not so much that it makes it go back, it has to do with the flowchart that is equivalent to the text. So, after we perform whatever action that is after the condition, the only outgoing arrow is to go back to ask the question again. So this is the actual. So the flowchart explains the meaning of a while loop. The text here, inside the algorithm is really using BNF to help us identify where's the condition and where's the action that I might need to do repetitively. But the meaning of what we need to do is in the flowchart itself. Okay? Absolutely. So the most important thing, we are running out of time now. The most important thing for you to do before this Wednesday, okay, because we do have class on Wednesday, is to make sure that you can differentiate between a conditional statement, which is a what if, versus a while statement. The do while loop is it looks very different, so I don't think people can confuse those two. But a while versus a if, they can be confused because the only difference, okay, is one starts with if, the other one starts with while. And then they are both followed by parenthesized condition and a statement. But the meaning of those two statements are different. So make sure you can differentiate between a conditional statement versus a while statement. Okay? So I'll see all of you on Wednesday, this Wednesday. Okay, I cannot tell, sorry. Hmm. Uh-huh. Okay. Uh, yeah. It will keep your highest score. Oh, average. Yes. You want to delete the second attempt? I'll see what I can do. Let me clean up first. The next class can come in. Hmm. Hmm? I said Wednesday what? No, you didn't pay attention.